Okay, now at this stage that we have been able to just create a model and install that into a model A, and that's going to be our Bayesian regression analysis. Now that's the time to just see that, okay, what has been the result of our inferences on that model. If you remember from our non-Bayesian models, we just go ahead with the function summary, and I just put the name of the objects which I have created, which is going to be the model A, and I'm just going to run this code and execute that by pressing Control Enter, and I see that, okay, I have lots of information which is somehow a different type of the things that we had in our non-Bayesian ones. There are lots of information in this, I should say, in this function. I'm going to talk about that as we just move along, but because at this stage the purpose of this tutorial is that to make a simple comparisons between, I should say, the inferences that we can throw from a Bayesian and the non-Bayesian, then as a result, we are at this stage, we focus at this column that we have here. It's somehow different from the non-Bayesians that we had in the past, that we had p-value. Now here we have the mean. The mean is going to be, I should say, the mean of, I should say, the inference that we have made from our Hamiltonian Monte Carlo into our parameter space. You see that for the intercepts, the mean value which we had inference about is 25.7, and the weight is going to be 0.3, and also we have an additional, I should say, inference about the parameter which is called which is called zima, and this is going to be 0.5. But what are they, and how can we just make a comparisons with the non-Bayesian ones? We're just going to go back to the diagnostics ones in the next tutorials. But at this stage, I'm just going to go there to the slides which I previously prepared to just go with the Bayesian models and see that, okay, the inferences which I made about the slope, it was about 0.3, and about the intercepts, it was 25.7, and also you see that as I talked before, that we talked about the model, that it says that it's going to be a weight. It's going to be the height it's a normal distribution with the mean nu and the standard deviation sigma. The sigma, which is the inferred, is going to be 0.5. And essentially that we said that the parameter in our model, which is going to be the nu, which represents the mean of the height, is going to be represented by the slope, and the intercepts, which we just made the inferences about that by the value which we saw that on, let's say, as a result of our stand model. I go back to the previous slide. You see that then as a result, our Bayesian inference just gave us the slope and the intercepts as these two values, which they are the inferences as a result of using the dynamic Hamiltonian Monte Carlo. Okay. Now, the thing that we just want to do, go back to the non-Bayesian and use maximum, I should say, likelihood estimations in order to find the estimates for the slope and the intercepts. In order to do that, I'm just going to write the non-Bayesian, and I'm just going to go ahead with the GLM model and write the arguments inside. As I said before on the previous tutorials, we learned that in terms of the syntaxes, the GLM model and the stand GLM model, they are somehow very similar, with the fact that we have the arguments with the GLM model that it allows us to define the priors for the parameters in our methods. Now I just go ahead for the formula. I'm just going to go ahead to just write the formula as the one which I had before. It's going to be the exact same thing. The height is going to be a function of the weight. And also, the other argument which is essential for this model is going to be the data that we are just going to run, fit the model with that. It's going to be the same data sets. It's going to be the woman. It seems that we have all the sufficient and required and necessary arguments for the GLM function. But before I just go ahead to just execute this model, I'm just gonna store the model into, I call that model B. and the model is going to be ready. I'm just going to go ahead to execute that, and in order to execute this model, I'm just going to go ahead to just press Control Enter, and the model is executed, and I have the model stored into an object. This is called model B, which is a list of 30 objects, and you can see the objects. If you just click on that, then you see the coefficients, you can see the residuals, the fitted values, the effects, and the QR decompositions. That's the thing which we're going to talk about that in the next tutorials, when we have multiple predictors that we have to just put the QR in our model. But however, at this stage, we just want to just make a simple comparisons between model A and model B. I'm just going to go ahead to just run the function, the summary, and for the summary, I'm just going to enter the model B as an object inside the function and execute it by Control Enter. And I see that I can just have some estimations of my model. And in this model, I see that, for example, it's somehow very familiar to you because we just worked on these things before. You see that for the coefficient stats field, we're going to focus. You see that we have the estimates, we have the t-value, and we have the p-value, which we do not have these, I should say, values with within the stand framework, within the Bayesian framework. Now I'm just going to get these values which I have here. You see that for the intercepts we have 25.72, and for the slope it's going to be 0.2872. And I'm just going to go back to the slides which we had here. For the non-Bayesian, then the inference which we made from non-Bayesian is going to give us these values. You see that for the slope, I got this one, which is going to be 0.287. And also for the intercepts, which I got it from the non-Bayesian framework, I got 25.7. Okay, now, before we finish this brief tutorial, then you will see that as a simple comparisons that we can just do it right now, we can draw a very interesting conclusion to see that these two models which we throw, they do not show a significant variations between the inferences that we had, which is going to be our slope, which was A. You see that the values are somehow so closely related to each other. And also for the intercepts, you see that the intercepts also, they are somehow identical. And as a result, you see that on this single variable linear regression, either using, I should say, the sampling algorithm in the using Hamiltonian Monte Carlo into our parameter space, or either using maximization likelihood estimations that we had, essentially we make somehow similar inferences about the slope and the inferences. And somehow we can expect that if we are just going to just go ahead and run to make some predictions, we have somehow similar predictions. But we have some inherent differences as a result of the philosophy which is embedded within the Bayesian framework as opposed to the non-Bayesian, which we are just going to discuss about them in the next tutorials. Also, within the next tutorials, we are just going to add more arguments into our Bayesian frameworks, adding more arguments, talk about the priors, and see that if we change the algorithms, what differences does it make into our inferences then. Okay, then we talk more about this stuff on the next tutorial.